Okay, this is the Unit 3 test review. Hopefully this video will get you ready for that Unit 3 test. As the problems are worked out, pay special attention, take notes, because you'll see problems very similar to this on the actual test itself. Alright, let's start out with some equations. In this case, we're isolating the variable x. This is a two-step equation. I'm going to undo the minus 8 that's being connected, because we always undo adding and subtracting before multiplying and dividing. I'm going to add 8 to both sides. Use the shortcut notation this time. I have 3x is equal to 30. I get rid of the 3 that's times the x by dividing by 3. Both sides, x equals 10. Remember, you can check your answers. Take the 10, substitute it back into the original problem. This 3 times 10 minus 8 equal 22? Absolutely. Over here, I'm going to subtract 7 from both sides. I'll write it the more traditional way. The plus 7 and the minus 7 cancel out. I have x over 2 is equal to 4. Get rid of the 2 that's dividing into the x. I'm going to multiply both sides by 2. Cancels out as a factor of 1. I have x equals 8. The next one has parentheses. So I have to simplify the left side first by distributing. 3 times x is 3x. 3 times the plus 4 is plus 12. Now it's just like the first example. I'm going to subtract 12 from both sides. I have 3x is equal to 12. I'm going to divide both sides by 3. And I have x is equal to 4. That's an equal to sign right there. All right, almost done here. Now, this next one, it has some simplifying to do, but it's not eliminating parentheses like in the last example. On the right side of my equation, I have like terms. The coefficient here is 8. The coefficient here, even though it's not written down, is 1. So I have 8x and I have a plus 1x. I'm going to combine those. 8x and 1x is 9x. Now the problem looks a lot more like the one above it. I'm going to add 3 to both sides. I have 18 is equal to, looks like 9x, and then I'm going to divide both sides. Solving for x, I'm going to divide both sides by 9. And I have x equals 2. Again, if I'm going too fast, you can always slow it down, click back, watch it a couple of times, make sure you understand, because you'll see problems like this on that test. Over here, I have the variable on both sides. This is the first one I've come across like that. 5y on the left, 6y on the right. Before I can do anything else, as far as solving it, I have to definitely make sure I get the variable on one side only, and that means first, check to see if anything simplifies on the left or on the right. There are no parentheses, there are no like terms, I'm good. Get the variable on one side. I usually get rid of the smaller one, so I'm going to subtract 5y from both sides. Now when I do that, you'll see that those will cancel. A plus 7 is positive 7. 6y minus 5y is 1y or just y. And then the minus 15. Now it's a little one-step equation. I'm going to get rid of the minus 15 by adding 15 to both sides. And I have 22 is equal to y, and there's my answer. Now remember, there are two special cases when the variable is on both sides, and we'll come across one of those examples here in just a second. But in this case, we get one single answer, y equals 22. Now even though this doesn't look like an equation, you need an equation to solve this. It says find the length of the side of the square. I have to find out what x is to find out the length of the side of the square. Now since it's a square, all 4 sides are the same length, which means this measure equals this measure. That means 3x minus 5 equals x plus 7. Now I didn't leave myself very much space here, but just like the last example, I have the variable on both sides. I'm going to subtract x. The reason I subtract 1x is because 1 is smaller than 3. I have 2x minus 5 is equal to 7. I'm going to add 5 to both sides. Again, I don't have much space here. Hopefully you can still see this. I have 2x equals 12. And then I'm going to divide both sides by 2. And I have x is equal to 6. Now that's not my answer. That's going to give me my answer. I have to take the 6 and either plug it in here for the x or in here for the x. I'll get the same value. This looks simpler. If I plug 6 in here, I have 6 plus 7, which is 13, and that would be my answer. Make sure once you solve for x, if they want the actual length of the side, not just x, you have to substitute back in to one of the expressions. Now this one it says to solve, but what I'm interested in here is if you notice that this is going to be one of the special cases. I have 6x plus 12 when I distribute through, and on the other side I have 12 plus 6x. I have the variable on both sides. If I subtract 6x from both sides, I get 12 is equal to 12, which is kind of weird. The variable drops out of both sides, not just one. And I'm left with a true statement. Remember, this is called an identity, And it means that for its answers, it's the set of all real numbers. Okay, if you remember, there's the example where you can have all real numbers. There's the example where you could also have both variables drop out of both sides, and the variable drops out of both sides, you're left with a false statement, which would mean no solution. That's called a contradiction. But this gives me a true statement. 12 does equal 12. All right? All right, the next problem says Joe needs at least $10. Write an equation to represent this situation. The key here is at least. All right, now it's an inequality because at least means it can be more than, it can be equal to, but it can't be smaller than. If I say I need at least $10, then at least $10 means 10 is the minimum that I can have. So I'm going to write x is going to be greater than or equal to 10. The equal to, because at least means it could be 10. The greater than means because it could be more than 10. I know at least sounds like it should be smaller, but at least means it gives a minimum, anything higher than the minimum of 10. That's why we have the equality. Now if I said at most, then it would be the other way around. It would be less than or equal to, because then that would be the cap. That would be the upper limit. Problem number 5 here says write an inequality to represent the graph. Now remember, if it's a filled in dot, it means it doesn't have the equal to, or it has the equal to, but if it's an empty dot, it doesn't have the equal to. This is a filled in dot. So I'm going to use the variable x, and I'm going to write greater than or equal to. Equal to because of the filled in dot, greater than because I'm shading to the right, and I'm looking at 6. X is greater than or equal to 6. Now if that was an open circle there, I wouldn't have the equal to, I would just have the greater than. I have 3 inequalities here that I'm going to solve. Now anytime you're solving an inequality, be careful. You solve them like equations, but you have to be very careful if you multiply or divide by a negative. Here to solve this, I'm going to multiply both sides by 3, which is positive. So the inequality sign stays the same. It's called same order. The 3's cancel. As a factor of 1, I get x is less than 27. But here, I'm going to solve for y by getting rid of the negative 5 that's times it. I'm going to be dividing by negative 5, both sides. And this is when the order reverses. The greater than or equal to becomes a less than or equal to because I'm dividing by a negative. It doesn't matter what I'm dividing into, it's what I'm dividing by, or what I might be multiplying by. So here I have y is less than or equal to, positive divided by negative is negative, negative 6. Now over here I have a 2-step inequality. I'm going to add 9 to both sides. I have 2x is greater than a negative 17 and a 9 is a negative 8, and now I'm going to divide both sides by 2. Now notice here I'm dividing by a positive. I'm dividing the 2 into a negative, but I am dividing by a positive, and that means you keep the same order. If you multiply or divide both sides by a positive, the same order. Otherwise, if you multiply or divide by a negative, you reverse the order. But this is going to be greater than, and it looks like negative 4. Now I have a couple other examples here that involve some of the ideas we've been talking about with equations and inequalities. This one says that the area of this is 95 square inches. This is 5 and this is x plus 7. We want to find x. So what I'm going to do is I'm going to multiply the two sides together. 5 times x plus 7. Now notice that the parentheses are there because the 5 is times all of this side. So length times width for the area of a rectangle, and the area is 95. So now I solve this. I'm going to distribute. I have 5x plus 35 is equal to 95. I'm going to subtract 35 from both sides. And those cancel out nicely. I get 5x is equal to 60. Then I'm going to divide both sides by 5. We should be getting pretty good at this by now. And I have x is equal to 12. And that's my answer because I was looking for x. All right, now, the last example doesn't look like it, but it's also going to give me an equation. It says that the area of a parallelogram, now if you're not sure what a parallelogram is, it looks like a rectangle that kind of got tipped over. We'll call this the base, we'll call this here, this perpendicular distance here, the height. The area of a parallelogram is 400 square centimeters. The formula is area equals base times height. So I'm going to write that down right here. If the base is 25, find the height. Well, I know the area is 400. I know that the base is 25. And we're looking for the height. So I just substitute in what I know, and now I'm going to solve for what I don't know. I'm going to divide both sides by 25. And 25 goes in that, I believe, 16 times. and I have h equals 16. So the height would be 16 centimeters. Now, if you look through these problems a couple times, make sure you understand how to work them out. I don't think you're going to be surprised by anything that you find on the test, but before you take the test, make sure you practice all of this, make sure you ask questions if you're unsure on anything, and as always, anytime you have math that needs to be done, practice, practice, practice.